In this video, I'm going to go over the basics of object orientation in Swift as coming from another object-oriented language, okay? So there are a lot of things that Swift can do that other languages cannot do, and there's a lot of things that other languages can do that Swift cannot do. Those decisions I leave to the designers and for you guys to find out what they are, but I'm going to go with a simple introduction to classes and interfaces or protocols as they're called in Swift and Objective-C. So let's start declaring a basic class. This, by the way, assumes that you know object orientation, you know about inheritance, you know about interfacing or protocols, okay? So, and you know about static and non-static methods. So here we go. Let's create the basic example with a class named shape. Okay, that's how you declare a class. Let's have one member variable, one instance variable here. That's going to be side, and it's going to be of type double. Okay. Now, each class has to initialize its member variables. Usually that's done in Java, for example, that's in a constructor. In other languages, it's called initializer, and so it is in Swift. And the method to initialize variables is called init. Okay. With no parameters, we can say that side equals 0.0, for example. That's how we initialize our side method, okay? And then we're going to create a little function here called getArea that's going to return a double, okay? And basically for now, it's just going to return side, okay? So it's just going to return the side for now. This is no shape has this, right? So this is some blob. So let's create a little variable blob, which is going to be a shape. This is how you instantiate an object of type shape. And the way you call a method on it is you say you say print blob.getArea. Okay, just so we can see it. So here it is, 0, 0, right? Now, there are other ways to initialize this. If I don't want to create an init method, I could simply just say, I don't even need to know the type will be inferred, I can just say that. Okay, and the class works just as well. So if I can initialize the variables up here, then I don't need to create the init method. Okay. Now let's create now a subclass of this. This is class square, and in each class that I create, I'm going to be introducing new concepts. Okay, so if there's something that questions that you have here, they might be answered as I create the other classes. So we have a class square that inherits from shape. Inheritance is denoted by this colon. If you have an interface as opposed to an actual class, interfaces go at the end of the inheritance list. So after the class that you inherit from, you say comma, and then the interfaces that the square implements, or the protocols that it implements. Okay, so let's create a class square that inherits from shape. Now in this case, my init method, okay, it's going to have a variable here, side, that's just the name of the parameter. It's going to be double. And what I'm going to do with this, remember my init now is going to receive a parameter. So when I create the instance, I'll have to provide a parameter. So, and what my side is going to do, first I'm going to initialize the superclass, just calling it like that. And then what I'm going to do is I'm going to say self side equals side. Basically, the self variable here is a reference to this entity. In Java, this is this. In Python, it's also self. In Objective-C, it's also self. So self is a reference to the entity, to the instance, to one of the current instance of square. Okay. So I do this self.side equals side to distinguish from the side inherited from shape here, and the side passed as a parameter here. Okay. Then so this is one thing that the class does, right? So I'm gonna now create a variable box. It's going to be a square, right? And I need to provide side And you see the helper here, the helper comes to the rescue, right? So box square of side 5. Now I'm going to do a little thing here. I'm going to print box, and look what happens. When I print the variable box, it just says square. It just prints the class name, okay? We'll deal with this in a second. Now, I want to override the function getArea. So if I do this, getArea double, and then the code, I get an error. If I want to override a function, I need to expressly tell Swift that I'm overriding this function. Okay? So here I'm going to, in this case, the getArea for a square is going to return side times side. Okay, so the variable side. Now notice I didn't use self here because in this function side, the only side that this thing can look up is the side in square. There are no sides in square, so it's going to go look it up in shape, and there it is, right? Okay, so it's going to return side by side. Now, I'm going to create another function, for example, that doesn't inherit from anything. Change side to, and then I'm going to have here a double. This function doesn't return anything, and what it will do is it'll set side to S. Okay, so then I can change the sides whenever I want. Okay, so now let's print a few things. Now we have a box is a square of side 5. Let's print, whoops, this helper is not helping at all. Let's print box dot getArea at this point, and we should see a 25. There it is, 25, because it's a square of side 5. I call the getArea method. Now I'm going to set the side, change side to 4, and then print box dot getArea. So here I have the first area is 25, the second area is 16 after I change the side to 4. Okay? Now this thing still prints box at the bottom, so I'm going to create a little bit of an enhanced method to print this, right? Enhanced function here. So I'm going to create func, I'm going to call it toString. This function returns a string, and what it's going to do is it's going to return a string with self.dynamic type. This is a variable that all classes have, okay, which tells it which is the class basically, with side. Okay, and now I will print box.toString, and you can see now how it's a square with side 4.0. So now if we look at this, what we've seen so far is we have a class with methods, a class that inherits from the class. We've seen a little bit about the initializers, okay, and methods, and also we've seen the methods. One more thing that I would like to treat here are static methods. So I can have, for example, a class mathUtils for math utilities, for example, where I can have a static function called square, for example, that receives a double object and returns a double. Okay, and what this function does is it returns n times n. That only returns the square, right? And then it might have another method, static func is even, that will tell me whether a number, an integer is even or not. It's going to return a boolean, and it will return basically the number modulo 2 equals to 0. So if this condition is true, then it will return true. If this condition is false, then it will return false, which actually matches whether a number is even or not. If the number is divisible by 2, this is true. Therefore, it's even, and the number will return true. And we can test this, and we don't have to instantiate this class at this point. We can just say, for example, we can just say something like, is 35 even? Then print, so a, we're going to create a variable a equals math_utils dot is even number 35, right? Whoops. And then we can actually print something like, is 35 even? Then I print a, right? And how about 34? And then I can call the function directly, math_utils dot is even 34, right? So let me see here. Is event? No, it's even. There you go. All right. So, oh, it's event. There you go. It's even. Now it all works. Okay. So then it says, is 35 even? False. And how about 34? True, right? So I'm calling my static methods, and I could call my square method and whatnot, right? So I could also print something like this. And this will say 3 to the power of 2 equals 9, right? It's the square of 3. So these are static classes. Now you know a little bit about classes, static, inheritance, and all that. The next video ends with a little bit about protocols and a more complicated example.